In this section, we'll deal with geospatial feature concepts and relationships. First of all is the idea of place. Place is something that is about us wherever we are, and it can be understood through several different means, one of which is to look at the humanistic context of place. What are the meanings of places that we bring to ourselves? What do we assign to landscapes? How do we understand the way that the experience of being in a place varies as we go literally from place to place? Then we bring in the concepts of location, and we'll deal a little bit more with that later. But basically, in terms of location, we can understand location and place from the point of view of absolute location, which has to do with pinpointing a place, latitude and longitude. Or we can deal with relative location, the situation of places. In other words, Lake Erie is situated in the Great Lakes region, in the eastern part of the Great Lakes region, and Cleveland is situated really at the southeastern tip of the Great Lakes, which gives it a completely different concept of place and meaning. The Great Lakes means something very different in Cleveland than it does, I would say, in Sault Ste. Marie. And here's one of those moments where if you're saying to yourself, what is Sault Ste. Marie? I'll say, don't exercise learned helplessness, look it up and think about it. So one of the things that you need to do then is start understanding how as geographers bring different concepts of place to the fold, and the data we start to map then means something specific for specific places. Well, how we bring that data into a data set, we're already aware of the importance of attributes and the attribute table. And so attributes essentially are the qualities and characteristics of those features. And features can be places. They might be points on a map, or they could be whole cities or what have you. They could be polygons. We know that already. And so in terms of the attributes that we're bringing in, we're talking about now the characteristics of that particular data set. It could be the name of a company and the address and zip code and phone. It could be all kinds of other things. But we see the world from a geospatial point of view through the experience of objects, those features, those are the rows in the table, and the attributes themselves. And we're essentially trying to create a digital version of reality based on that. Everything we do, we're essentially doing a representation that's a model of reality. So that's the concept of the attributes. Attributes are, again, those characteristics of the data, of the objects. Objects themselves, we see here, are the actual features. Roads, land use categories, elevation. It could be points, it could be lines, polygons, could be grid cell related data. But without the attributes, the objects don't really mean very much. They're just points on a map, or they're polygons or objects or what have you. They're features, but they don't mean much without the attributes. Well, then what do we do with all that stuff? And that brings us to maps. You've thought already in Geography 1700 about the meaning of maps and the importance of maps, and about good maps and bad maps. And a good map or a bad map, its success depends entirely, well, it depends on its design, it depends on how it's being used, it depends on the audience, it depends on what the intended use is. Does it match the needs of the user? Those are all important factors, but it's all dependent on those characteristics. So yes, there's bad cartography out there that would be a bad map under any conditions, and hopefully you won't make any of those. But much of this depends on the use, the audience of the map. And so it's really important to understand what data can be used in what ways to deliver what message and to what audience. And those are all important and critical factors. And then we come to the relationships among objects. So topology is an important factor for us because it helps us understand those relationships. In other words, in this case, topological factors deal with the behavior of objects. And so the topological properties have to be defined for those objects and understood for those objects in order for us to effectively use data. So what is the relationship? Is a point within or next to a polygon? Does a point sit near a line but not on the line? Is it allowed to sit on the line? Is it allowed to be in an area versus next to an area? We come to concepts of the dimensionality, that is the distinction between point, line, area, and volume. The adjacency, including the touching of land parcels, counties, nation states. Connectivity, which includes the junctions between streets, roads, railroads, and rivers. In other words, you need to define and understand how those objects relate to one another. Maybe two roads intersect, but there's a bridge and one's a controlled access highway, and they don't really have a relationship. Or maybe the relationship is that there's an on-ramp. So there are lots of things you have to think about when you look at putting data together. And then the concept of containment, when a point lies inside or outside of an area. So those are all important factors to think about. And as we move into the next section, we'll talk more in specifics about then how those relationships among features take place.